This video is the last in a series of videos in which I attempt to bring out concepts related to multiplication in the world of natural numbers. You may be someone who is already aware of how to multiply two natural numbers but may be curious as to why the method works. Or you may be someone who is totally new to the multiplication process. In either case, you should find these videos useful. If you have watched the previous videos in this series, you should know what happens when the multiplier is a single or double digit number, that is, any number from 1 to 99. In this video, I will attempt to bring out a generic process for multiplications, one that works for any multiplier. As always, I will take examples to explain. I will begin with a 3-digit multiplier. Say I need to find out what is 234 times 253. Expanding my multiplier 234, I can write this as 200 plus 30 plus 4 times 253. And since addition is commutative and associative, I can write this as 4 plus 30 plus 200 times 253. Multiplication distributes over addition. So I can write this as 4 times 253 plus 30 times 253 plus 200 times 253. Which means to find out the answer to this multiplication, I need to do these 3 multiplications and add the results to get the final answer. For doing this, I will now write my multiplication problem like this and use the space under this line to record the results of 4 times 253, 30 times 253 and 200 times 253. 4 times 253 involves a single digit multiplier and we know how to do this. 4 times 3 gives me 12. I retain 2 and carry forward 1. 4 times 5 gives me 20. Adding this 1 gives me 21. I retain 1 and carry forward 2. 4 times 2 gives me 8. Adding this 2 gives me 10. I now need to find out what is 30 times 253. We know that multiplying any number by 10 simply shifts the digits of the number to the left by 1 place and the vacant units place gets populated with 0. Hence, 10 times 3 equals 30. So, 30 times 253 equals 10 times 3 times 253. Multiplication is associative. So this is equal to 10 times 3 times 253. Again, multiplying any number by 10 simply shifts the digits of the number to the left by 1 place and the vacant units place gets populated with 0. So we just need to find out what is 3 times 253, shift the result to the left by 1 place and put a 0 in the vacant units place. This is the same as putting a 0 here and then doing 3 times 253. 3 times 3 is 9. 3 times 5 is 15. I retain 5 and carry forward 1. 3 times 2 is 6. Adding this 1, I get 7. Now I need to find out what is 200 times 253. We know that 10 times 2 gives us 20. Multiplying this by 10 will give us 200. So I can write 200 times 253 as 10 times 10 times 2 times 253. Multiplication is associative. So I can write this as 10 times 10 times 2 times 253. So all I need to do is find out what is 2 times 253, shift the result to the left by one place and put a 0 in the vacant units place to account for this 10 times. Again shift one place to the left and put a 0 in the vacant units place to account for this 10 times. This is the same as shifting the result of 2 times 253 two places to the left and putting zeros in the vacant tens and units place. We can also think of this as putting zeros in the units and tens place and then finding out the result of 2 times 253. 2 times 3 is 6. 2 times 5 is 10. I retain 0 and carry forward 1. 2 times 2 is 4. Adding this 1, I get 5. It is now time to add the results of our multiplications. 2 plus 0 plus 0 gives me 2. 1 plus 9 plus 0 gives me 10. I retain 0 and carry forward 1. 0 plus 5 plus 6 gives me 11. Adding this 1, I get 12. I retain 2 and carry forward 1. 1 plus 7 plus 0 gives me 8. Adding this 1, I get 9. I bring this 5 down and I am done. Let us now examine the method. I first multiplied by the digit in the units place, 4. This was straightforward. I next moved to the tens place. Before multiplying by the digit in the tens place, I placed a 0 here in the units place and then multiplied. I then moved on to the hundreds place. Before multiplying by the digit in the hundreds place, I placed 2 zeros here and then multiplied. I then added up to get my final result. It is worth noting here that every time I move to the next digit in the multiplier from the right to the left, the number of zeros I place increases. Keeping this in mind, let us look at another example. Say 30890 times 2531. I'll perform the multiplication using the generic method that I have brought out in the earlier example. I'll write the multiplication like this. And perform the multiplication. I need to multiply by the digits of my multiplier, starting with the digit in the units place and moving towards the left. Once I perform all the multiplications, I need to add the results. I have a 0 in the units place. 0 times any number is 0, so I can ignore this and move on. Next, I need to multiply by 9. But since I have moved one place left, I need to put a 0 first. 9 times 1 is 9. 9 times 3 is 27. I retain 7 and carry forward 2. 9 times 5 is 45. Adding this 2, I get 47. I retain 7 and carry forward 4. 9 times 2 is 18. Adding this 4, I get 22. Now it's time to move on to 8. But since we moved one place left, we need to add one more 0 compared to last time. So 2 zeros in total. 8 times 1 is 8. 8 times 3 is 24. I retain 4 and carry forward 2. 8 times 5 is 40. Adding this 2, I get 42. I retain 2 and carry forward 4. 8 times 2 is 16. Adding this 4, I get 20. Next, I have 0 again. Again, 0 times any number is 0, so I can ignore this and move on. Now it is time to multiply by 3. But I have moved 2 places compared to the last multiplication that I performed, so I put 2 extra zeros for a total of 4 zeros. 3 times 1 is 3. 3 times 3 is 9. 3 times 5 is 15, I retain 5 and carry forward 1. 3 times 2 is 6, adding this 1, I get 7. And I'm done with the multiplications. Now it is time to add the results of the multiplications that I have performed. 0 plus 0 plus 0 is 0. 9 plus 0 plus 0 is 9. 7 plus 8 plus 0 is 15. I retain 5 and carry forward 1. 7 plus 4 plus 0 is 11. Adding this 1, I get 12. I retain 2 and carry forward 1. 2 plus 2 plus 3 is 7. Adding this 1, I get 8. 2 plus 0 plus 9 is 11. I retain 1 and carry forward 1. 2 plus 5 is 7. Adding this 1, I get 8. I bring the 7 down and I am done. In this video, I intuitively brought out a generic process for multiplication in the world of natural numbers. I hope you found this video useful. Thanks for watching.